Just want everybody to know, unless we get 1,000 attendees, I'm not doing the webinars.
Oh my God, call your friends.
Thank you for our second Hal Pomeranz webcast on the Linux Command Line Dojo. I don't even know what kind of awesomeness Hal's going to drop in this webcast, but it's going to be cool. For those of you that don't know, Hal Pomeranz, I think, is SANS instructor number 1 or number 2. I can't remember.
Longest tenured instructor.
But wasn't Randy right around the same time, like either before you?
He came in after me. There are people before me, but they don't teach for SANS
They don't
anymore.
count, really. Longest tenured SANS instructor. SANS fellow, I should say.
Oh, yeah.
I never made it to fellow. But I'm cool with that. I'm all right. I'm fine, Hal. And Hal is one of the few people on the face of the planet that can cradle me like a baby, which is cool because sometimes I do need that from Hal. Once again, another big brother to me for years, easily one of the smartest people I know. I once went to dinner with him, George Bakos, and Bill Stearns, and I was so incredibly stupid. I should have shut up, but I didn't. And they still hang out with me, and that's nice of them. So Hal, with that, please take it away, sir.
All righty. Thanks, John. Hey, welcome to another one of these command line things. Last time we kind of broke the platform, and that was fun, so we thought we'd do it again. You know, for attendance is down for obvious reasons right now, but I'm hoping that folks will be able to watch this on, you know, archive or whatever and get the tasty command line goodness. You know, there's so many people on the last one that we just couldn't get all the questions answered. And the Black Hills folks were kind enough to send me the questions. And I just cherry picked a couple of the questions as starting points for this webcast. There are a bunch of good questions. I mean, like we can live off the questions for months in this thing. You know, the story of me, for those of you who didn't make the last webcast, I've been doing Unix before Linux even existed. I started my career as a Unix sysadmin. I worked a bunch of different places. Some of them are famous. You all may have seen the Command Line Kung Fu blog that Ed Scotus and Tim Medina and I used to write. Still a lot of good content there, even though we're not updating it. And you'll be able to find the slides for these webcasts at the URL that you see on the screen there. You know, it seems like this might become a regular thing, so I've started to create this area on my website with different directories for each month, so you can go back and look at the archives and things like that. So you'll find the content and the slides for today's presentation are already there. I've already uploaded them, and last month's slides are there as well, along with my bash history from last month's presentation, in case you don't want to watch the video to see the commands that I'm typing. And the videos get posted to the Black Hills channel. Okay, right, let's get to the magic. So last month, I was showing you my command line histogram thing, which is easily one of my favorite little shell idioms, right? You know, you got some data and you want to count it. So, you know, whatever the data is, and in this case, we're doing processes per user, you could pipe it into sort, which, you know, by default does an alphabetic sort, and then unique, you know, normally smashes the duplicate lines together, but with unique-c, you get a count of the number of duplicate lines. And there were a lot of questions in the channel about doing sort-u instead of sort pipe to unique. And yes, sort has a built-in -u option that does unique, but I'm piping it into the actual unique program so that I can do unique-c here to get the counts. And then I pipe it into another sort, but this is a numeric sort, right? So we do -n to do numeric sorting so that I get this nice listing with, you know, like the number one, you know, user in terms of processes first, you know, which is usually root on a Unix system, and then me, the user who's logged in, and then a couple of, you know, users for different applications are registering as well. Okay, so so that's basic sorting, right? You can sort alphabetically and you can sort numerically, but there were some questions that came up in the chat that we didn't get a chance to address, and sort's a very cool program in a lot of ways, and I wanted to talk about some other little bits of magic that you can do with sorts. So one of the questions was, do you have to sort on sort of the whole line, or can you sort within individual fields of a line of information? And yes, Virginia, there is a Santa Claus, right? Yes, you can sort on individual fields. Okay, so the trick is the -T delimiter and then -K, which specifies the key field or fields that you want to sort on. And the one I've got on the slide here is one of these classic sorts that's actually very useful from a kind of incident response perspective. So there's my terminal window. Okay, hi. Okay, so you've got an attacker and they've broken into your system, they've broken root, and as a backdoor, they put their own UID0 account and they've buried it in the middle of your really big local password file. But if you sort, password files are colon delimited, right? So my delimiter T is colon, and then the field I'm going to sort on is the third field. So the key field, I'm going to start at field 3 and I'm going to end at field 3. And the syntax here is a little bit cumbersome, but that's the way it works, which is the user ID field. So I'm going to sort by user ID, and of course that's a numeric field, so I'm going to sort numerically my password file. Okay, and so what that does is, no matter how big the password file is, all the UID0 accounts are going to bubble up to the top, and you can see they've added the evil Lynn account. So, this is actually a very useful little sort. I might combine that with a little bit of, head to make it so that you can, just see the first part. It doesn't scroll off your screen. Or if you didn't want to do that, you could, of course, change the sort order, -R. Right? And now 0 is at the bottom, right above your shell prompt, right? And there you go. So yes, you can absolutely sort on individual fields. You use T to specify the delimiter. You use K to specify the fields you want to sort on. Now, you can, change this around in all sorts of different ways. It doesn't make sense for this particular example, but if you wanted to sort on multiple fields, the syntax here is starting field and then ending field. So this would sort on fields 3 through 6, right? Which again doesn't make sense for a password file, but that's the syntax. But what if you wanted to sort on different fields? And the reason I sort of got started in this whole example was a question that came up last month, which is, how do you sort IP addresses, right? So, think about IP addresses, and I made a file of random IP addresses, right? Okay, so you've got a bunch of random IP addresses. So it's, obviously 4 numeric fields separated by dots, right? And I want to sort on the first field, and then I want to sort on the second field as a second order key, and then the third octet, and then the fourth octet, right? Okay, so the problem is that the naive thing, just sort -N, doesn't work for you, right? So if I just did sort -N on my IP address file, I pipe this into like head -20, so I'm not scrolling all over the place. It looks at first like, oh, okay, like things are actually pretty good. Like the first, the 0s, the 1s, and the 2s, like those are actually all sorted. But then look down here in the 3s, right? So things are not so good here because it's treating this sort of naively like a decimal number, right? So 3.33 is bigger than 3.234. So sorting numerically on just the sort of the first two fields, that's the right thing to do. But it's not actually the right thing for IP addresses, where it's not a decimal number. It's like each octet is independent. And so that's where being able to sort on multiple fields comes into play. So actually the right sort for IP addresses, and admittedly, this is kind of a gross command line, actually goes like this. So we're going to use dot as the delimiter, right? So -t dot. But then we need to sort on each field individually. So K1, 1. And yes, the trick is you can have multiple fields and it will just sort them in the order you specify them on the command line. Right? And so this will actually sort the IP addresses properly, right? You can see here now like 3.33, 3.33, 3.54, 3.105, 3.109, and so on, right? It actually gets the ordering correctly. So yeah, although it's kind of gross, this is the right sort for IP addresses. And anyway, in case people were wondering, you get to use this one every now and again. It's a little clunky, but there it is. By the way, another interesting thing about the sort command is not all the fields have to be numeric. Some could be alphabetic, and some could be numeric. So you can actually have modifiers after the key fields. So let's go back to the password example for a minute here, right? So initially, I'm just sorting this thing by the numeric user ID, right? Okay. Now, suppose, though, I wanted to sort also alphabetically by the username field, which is field 1 here. Okay. So we could actually redo the command. So I'm going to sort on the UID field, and I'm going to sort that one numerically. So you can add the modifier after the field number, right? And then I'm going to sort on the first field, but I want to do a reverse sort on that one. So root appears before Evelyn. And so there you go. So yeah, you can not only sort on multiple fields, you can modify the sorting behavior of individual fields using sort of the normal sort modifiers at the end of each field declaration. Had it been me, I would have done away with the comma syntax and just specified the fields individually. And if you wanted to do a range of fields, you could always do like K dash 3-3. But anyway, I didn't write the sort command. It wasn't up to me. I blame Brian Kernahan most likely for that one. So it is what it is. Anyway, so sorting is cool, right? Now, to do the IP address example, I had to generate a bunch of random IP addresses. And yeah, I could have gone and just grabbed a bunch of IP addresses from my DNS logs or something like that. But I was too lazy. I just wanted to whip them out with a little command line kung fu. And it actually occurred to me that the command line kung fu that I did to generate those random IP addresses is actually kind of interesting and entertaining. So let me show you a couple cute little things that are built into the bash shell. And if you're going to say that the bash shell is overloaded with functionality, I'm not going to disagree with you. So there's an environment variable in bash called $random. And if you echo $random, you just get a random number between 0 and 32K. Now, obviously, the octets in an IP address range from 0 to 255 or 0 to 254, depending on how you're feeling. So, but that's easy enough to fix, right? I'll just do a little math. Just do a little modular arithmetic here. So you can do math in the bash shell with this $paren syntax. I'm going to do $random modulo 255. And now I'm getting random numbers between 0 and 254. So then an IP address is just that 4 times separated by dots, right?
Hey Hal, quick question from the audience.
Go ahead.
Do you need to watch the previous video to be able to understand today, or is this?
Oh, no. I mean, these examples were inspired by questions from the previous video, but this is a standalone thing. I'm not, relying on anything I showed in the last webcast. All right, so look, it's a random IP address. Okay, so cool, right? Now I needed about 1,000 of these. Just, so for I in, the bash shell has a range operator, which is that, do my last command, bang, bang, done. And I'm going to save that output in a file. Okay. And so the bash shell is a programming language, right? And you can get a long way in bash, ignoring the fact that the bash shell is a programming language. But for things like this, it's useful to be able to throw down a quick loop. Now, the bash, before anybody jumps in the chat and starts, saying, oh, but bash has a C-style for loop. Yes, bash absolutely has a C-style for loop. And I could have done this, for I get 0, I less than 1,000, I plus plus kind of thing. But honestly, I find that this range operator is a heck of a lot easier for iterating a certain number of times, right? So, yes, bash really is a programming language and does have, programming language style for loops, but it's also a scripting language. So do whatever is easiest for you from a programming perspective, and if the C style for loop fits your head, then so be it. But for me, this is easier, right? And I got to show you the range operator too, which is kind of neat.
Hey Hal, we got a question.
Mm-hmm.
Using the random IP address trick, how do you make sure they're not any of the reserved IP spaces from Chris?
Yeah, right. I mean, so of course I'm not worrying about that at all. Okay, since you asked me, I could do something like I'm gonna do the loop, right, and generate 1,000, and then I'm just going to pipe that into grep minus v, right? So don't show me things that match a pattern. Actually, let me use egrep to do extended regular expression syntax, because egrep allows me to do either or, right? So get rid of things that match 10 dot, actually 10 or 192.168 or 172. Now you can't really do CIDR notation, so I'd have to do some crazy thing. So let's see, once like 172.16, that one's ugly, but anyway, you get the idea. So 172.16 and so on. I don't know, 172.17. I'd have to figure out a way to do the masking. But I mean, that's the way I'd approach it. You filter out stuff you don't need. Now, of course, you're going to end up with less than 1,000 IP addresses this way because you're filtering some of them out. But in any event, anyway, there you go. All right. So yeah, loops are cool, and you can do a lot of neat stuff with loops, but there are also other ways to iterate in the bash shell. And so I wanted to lead up to another question that we had from last month. Another kind of iteration operator in the shell is the find program. Okay, so find in bash in Unix is how you search through a directory of files and do something over that directory of files, whether it's just print out file names or execute a command. It allows you to walk a directory structure and do something. Now, the syntax for find actually trips people up quite a bit, I find, when they're first learning Unix, because the find command, being one of the early Unix commands, actually uses a sort of unexpected syntax that messes people up. So look, at its simplest, you just say find, and then you specify the directory that you want to search, right? So starting at the dev directory, I want to search through that directory, and then you specify the files that you want to match. And find has all of these different criteria. But one of the easiest ones is type what kind of file. And I'm just going to say type F for regular files. And this find command that I'm showing you, I mean, it's not arbitrary. This is another one of these neat little blue team tricks. In the days of user space Linux rootkits, attackers would love to put stuff into dev, like configuration files for their rootkit and stuff like that. Because dev is just this huge directory full of, garbage looking file names. Right? And so, if the attackers called their file like dev tty s55 or something like that, you might not notice it in the crazy listing of all of these different files, right? But the thing about the files under dev is that they're not regular files. They're device files. There's special kinds of files in Unix, right? So having regular files in dev is actually unusual. So find dev type F would quickly show you if attackers had placed any regular files into dev trying to hide them. And it was something we liked to do a lot back in the days when user space Linux rootkits were more common. These days, if you do that command on your Linux system, you may get some output from the dev.udev directory. That's expected. Dev.udev is where you find stuff for pluggable devices like USB devices and things like that. But if you see like a regular file named dev, SDX43 or something like that, that doesn't really belong in dev. Okay? So there's all kinds of different things that you can do with find, right? So for example, another useful one after you've had an incident, find from the root, okay? But I only want to focus on the actual root file system. I don't want to descend into users' home directories and things like that, or say var if that's a different volume. So you can use the xdev option to say only search the root volume and not the whole file system, right? So find within the root volume files whose last modification time is less than 7 days, right? So show me anything that's been modified recently. And yeah, your attackers could change their timestamps with touch and things like that, but it's amazing how much they don't, right? And so this can be, a good way of quickly zeroing in on, oops, whoa, of course I should probably be rude to do that. Hold on a minute. All righty, try that again. Find from the root and keep it in the root. Files whose last modification time is less than 7 days. So the minus means less than and 7 days. Okay, so show me everything that's been modified recently. Oh, look, the evil lair directory, right? That just showed up. That's not normal. So, this would just be a good, quick way to see recently modified files. Obviously, you're going to get some stuff that's just operating system noise. I mean, stuff appearing in temp. Some of it might be, your crypto miner du jour, but a lot of it's just normal operating system wastage kind of thing, right? So you can also search by name, file name, and another search that I like to do: find from the root files. Directories. So type D means I want to only see directories, but in particular, I want to see directories whose name begins with .anything. So, yes, you can have multiple search criteria, and the default is that it's an and. So it's both, I want both directories and directories that are named by, leading dot. Okay. The other thing is when you're using wildcard patterns, like I'm doing here, you got to make sure to back whack the wildcard so that it gets passed into the find command rather than being globbed up by the shell. Now, why do this find? Well, because outside of user home directories, directory names beginning with dot are just not that common in Unix, okay? So, but again, you'll sometimes see attackers using directory names starting with dot for their installation directories because, of course, file and directory names that start with dot aren't normally displayed when you do an ls. Okay, so this is another one of these useful find commands that looks for people doing hinky things. So look, within root's home directory or within the etc/CK directory, sure, dot named directories are fine. And even under var and temp, okay, right? But, again, it makes the evil lair directory pop right out because that doesn't belong under user. So, fun things you can do with find, right? And there are lots and lots of different find options for searching on different things. And find expressions can get arbitrarily complicated because, while the default is to and things together, you also have or and not and all sorts of, different logical operators, including parentheses, right? To make these, sort of really complicated sorts of find searches. And another one of the classic ones is the one I'm about to show you. So I want to find from the root things that are regular files and that have the permissions bit 4000. That's the set UID bit for those, that's set GID, right? Or permissions 2000. That's set UID. Get that right? Yes. No. Sorry. 4 is set UID. 2 is set GID. My bad. Okay. So basically what this is saying is show me all of the set UID and set GID programs on my system. And, again, in an incident, you may have attackers either setting the set UID bit on programs that shouldn't have it, like a shell, for example, as a backdoor, or adding their own set UID and set GID programs. So if you have a list of the normal set UID and set GID programs from an uncompromised machine, you could use this search to compare against the list from a compromised system.
Hey, Hal.
One important, yeah, go ahead.
I had a couple quick questions. One, Ken just asked, how did Hal just delete everything from the rest of the command from where his cursor was?
Okay, so that one here, I'm using the normal sort of Emacs editing mode. This is bash, right? So Emacs is the default. You can get it to use VI editing commands. But in Emacs, if you want to delete the rest of the line, it's Control-K.
All right. And then the other question that we had was from Martin. He said, could you go over a little bit of the -exec a little bit more?
A little bit of the what?
-exec.
Oh,
yeah.
Yeah. Oh, we're getting to -exec. Hold it. Wait for it. We're getting there.
Getting there. Okay.
Okay. So a little bit about the syntax of this command. You see the minus sign in front of the permissions? Okay, that means match at least that bit, but other bits can be set as well. Without the minus sign, it would be an exact match for a file with permissions, 4000, which of course there's no file in the operating system that's only going to have set UID and no other bits set. So usually when you're searching for permissions, you're usually doing kind of an inexact match, and you definitely want to use the minus sign, right? It says, this is the bit I want to match. I don't care, the other bits can be set or not, right? I mean, if you really are searching for exact matches, you can do it that way. The other thing I wanted to mention is it's really important when you're doing this search that you only search for regular files, because directories in Unix use the set UID and set GID bits, but not for the way executables use set UID and set GID. So we had a Unix trivia question in the last one, which is, where does the command name grep come from? So my Unix trivia question for the class today is, what does set GID on a directory mean? And we'll let people throw that into the chat.
Yeah, I'm watching Discord and the chat as well. Yeah, I don't think there's any takers. TP Dragon is coming. Maybe. I'm going to say he's taking too long. Hal, go ahead.
So set GID on a directory actually changes the way group inheritance works. So normally, like if I were to create a file in a directory, the group owner of that file would be me, my group, whatever my default group is. Yep, and TP Dragon actually got it right. With set GID on a directory, the new files created in that directory inherit the group owner of the directory, which is useful if you're doing like a group software development project or something like that, and you want to preserve group ownership and group writability for the group. Anyway, so they overloaded the set GID operator on directories to make it do something useful, because Unix permissions are too coarse, frankly. So they had to overload operators to do crazy things. So anyway, yes, can we get TP Dragon something like, Backdoors and breaches set or something?
Yeah, TP Dragon, if you want to shoot an email to myself or Jason at blackhillsinfosec.com, we will get you something out as soon as, we're all out of quarantine.
So anyway, let me fire this command just so you can see what the output looks like. There's actually less set UID and set GID programs in the operating system than you might think. the Unix developers in general have been working to kind of drive out set UID and set GID programs because, frankly, they're dangerous. If there's a vulnerability in them, they quickly become a privilege escalation, and so on and so forth. So actually, there's maybe less set UID and set GID programs than you might think in the default install. But this is one of those classic, find commands as well, and it shows just how complicated some of these finds can be. I have another one that I like to do in my SANS class. So find from the root. In this case, I'm going to do directories that are named either bin or sbin or named lib, right? So these are directories that you might want to monitor with like a file integrity assessment tool like Tripwire or something like that. And I think, people are honestly surprised at how many of these there are in a typical Unix system. So how many do you think? And we'll do it by orders of magnitude. It's kind of like the jelly beans in the jar guessing game, right? Like how many jelly beans in the jar? So how many directories in my root file system do we have that are named bin or sbin or lib? Do you think it's, less than 10? Do you think it's sort of tens of directories, hundreds of directories, or do you think it's thousands of directories or more? And I'll let people think about that for a little bit. And wow, Bill Stearns checking in with the horrific egrep for filtering out reserved IP addresses. Thank you, Bill.
Scared. And he probably typed that in from memory. Just letting you know.
I'm assuming he cut and pasted from a script that he already wrote.
No, I've seen him do that crap like by hand,
I know.
really fast. It hurts my head. So
we're getting some answers to my jelly bean question. Most are thinking in the tens. I'm seeing one or two people saying hundreds. It may surprise you to learn that it's in the hundreds, and on a more fully installed operating system than the one I have here, it can be actually several hundred directories. Now, to be fair, it's a little bit of a misnomer here. I mean, if I show you some of the actual directories, I think you'll agree that some of these are not exactly critical core operating system directories, right? Like, I don't really care so much about the, temp VMware tools distrib, lib and bin directories, right? That's just, when I was installing VMware tools, I'm not so sure I care about all these different open JDK lib directories and stuff like that. But, the reason I show people this is there's a lot more of these directories than people think about. For example, a lot of people forget about things like user local or opt or whatever your third-party software installation directories are. So just think about it. There's a lot more of this stuff in the OS than you might think. And it's another fun little example of a find command. Okay, so we had a question about exec, right? So far, I've only been showing you printing stuff out, right? So we're matching, file names or recently modified files or whatever, and we're just printing out the matching files. But find actually allows you to execute commands when you hit a match, right? So if you reach a matching file, you can do something, right? For example, I could, here's my var log directory, right? Okay. And I've got all of these old logs that I want to gzip. Okay, so I want to gzip, let's say anything that's more than, I don't know, 2 weeks old. Okay, so I'm going to find in var log regular files where the last modified time is greater than 14 days. So plus means greater than, right? And when I find that thing, I want to execute the following command. I want to exec gzip on the file I found. So you use this open curly brace, close curly brace as the place in the command where you want find to substitute in the file name, the matching file name. And then you need to end the whole exec command line with a semicolon, which of course, again, is a special character in the shell. So you have to back whack escape it. Now, I don't want to do absolutely every file under var log. Let me just do files under var log that match the pattern *-20 something. Okay, so I don't have to search the whole directory. I could actually, in this case, I'm using wildcards just to search a list of files. Okay, so this is gonna, find every file matching my pattern, which is, things like boot log 2018, blah blah blah. And if it hasn't been modified in 14 days, I'm going to gzip it. Okay. Okay, and now we've got, all these files that have been gzipped. But for example, the most recent copy of the messages log and the cron log, I left those uncompressed because they're recent enough that I might want to refer back to them. Okay, so that's find exec. And again, I admit that the syntax here is a little bit weird. And again, I blame Brian Kernahan. Brian's never going to see this. I'm just waiting for like the nasty email from Brian Kernahan now, but okay. Anyway, so sorry, Brian, I don't mean to throw you under the bus. You might not have even written the find command, but you wrote so many useful Unix commands that I'm just going to say it's you. Okay, so yeah, that's find exec, right? I'm going to actually cd over into the var log directory, and I'm going to ungzip these files. So I'm going to gunzip star.gz. Okay, so things are back the way they were because it turns out that find exec is really inefficient because the way the find command works, it's running a separate gzip process for every single matched file. Right now, in this case, I was only gzipping, a dozen or two files, and it didn't really make a difference. But if you've got a lot of files, that's a lot of processes being spawned, okay? And it actually really slows down your find performance. So the real sort of Linux Uber hint here is don't use -exec in find. Instead, you use the xargs command. Okay? So, same find command. I'm going to find var log regular files that haven't been modified for at least 14 days. But instead of doing #exec, so this is just going to give me a list of files, right? Okay, so there's all the files, right? All right. I'm going to pipe that list of files into the xargs program. Okay. So xargs takes a list of files on its standard input, and it invokes the command you specify on that list of files. And if the list of files is small enough, it'll only execute a single copy of the command. If the input list of files exceeds the command line limit for your operating system, the xargs knows that, and it will run the fewest possible gzip commands in order to do what you need to do here. And it is much faster, right? So much faster, because now I'm only doing one or two gzip commands instead of a separate gzip command invocation on every single file. And you can do arbitrary command lines. So let me show you another one of my favorite shell idioms, and I'm also going to demonstrate the efficiency gain that you get of find exec versus find xargs. Okay. All right. So, oh, and by the way, I should just show you that the same gzip happened with xargs. Okay. All right. Okay. So let me do another find command. Find under user include regular files. And I want to search through those regular files for some particular string, right? It doesn't have to be user include. It could be any directory where you're looking for a particular string in the content of those files, okay? So first I'm going to do it the naive way and exec grep -L for whatever my pattern is. I'm going to search for path max, okay, from the files that I find. Okay, so again, we use the open curly, close curly to be the substitution location for the file name, and the command with a semicolon. Okay, so I'm going to search within each file for the string path max. -L for grep means only output the name of the matching file and not the matching lines. Okay, so this will give me every file under user include that includes that string. Cool. And path max is actually a fairly common macro in these files, and you can see it's actually included in multiple files. Okay, cool. Now, how long did that take? So I'm going to demonstrate to you the power and efficiency of xargs. So I'm going to do the same find command. I'm going to send the output to dev null so that the actual output doesn't impact how long this command takes to run, right? I just want to see how long it takes to execute the greps. And I'm going to use the built-in time operator within the bash shell to give me sort of a rough benchmark for how long this command takes to execute, okay? Okay, so that took almost 6 seconds, right? 5.8 seconds. Cool beans. Now, let me do the same thing, but instead of find, I'm going to do it with xargs. Okay, so it's going to do exactly the same thing, search for the same string, and I'm going to again send the output to dev null just so that that doesn't permute the experiment, right? So how long is this going to take? Yeah, right? Like literally 2 orders of magnitude less time. And this is why you want to use xargs. Okay, and now you're saying, Hal, you don't need any of this because grep has a recursive operator, and I could just do grep -RL for path max.
That's exactly what Lee just typed in.
Yeah, I know.
You've taught this before, Hal.
I know. Okay, so sure, fair enough. If you're using Linux and you've got the free software foundation version of grep, then yes, you have the recursive option. The fine thing came from an era when we were doing old school Unix and Richard Stallman hadn't started doing all this stuff. Okay, so but just as a point of interest, let's consider the efficiency here, right? Okay, so this grep -RL command is effectively the same thing that I was doing with the find commands. So how long does this take? Not much less time than find pipe to xargs, which I mean actually is sort of surprising to me that find pipe to xargs is as efficient as it is compared to a purpose-built program with an internal iterator like grep-r. It's pretty amazing that you can pipeline output from one command to another and still be within the same sort of order of magnitude of performance as a single purpose-built command that's written, in C or C++. So anyway, yes, on Linux, you really don't need to do this fine, in particular with grep, because grep has a recursive operator. But, those of you who are on, Solaris or AIX or HPUX may appreciate the value of find piped into xargs. And anyway, so, this xargs thing and -exec was one of the questions that came up in the last webcast. And so I thought I'd do a little bit more about that. One of the things that can mess you up is, what if you have files and directory names that include spaces? Because xargs will perceive those as separate arguments and mess you up. So again, on Linux, the find command has a -print0 option. And this means produce the output as null delimited strings rather than new line delimited strings or whitespace delimited strings. And the xargs command on Linux has a -0 option, which means you are reading in null delimited strings. And so this will protect you if the file paths that you're outputting happen to contain spaces. And if they don't contain spaces, it still works, right? So in any event, if you're running into problems because the directory that you're going through contains files or directories with spaces, the -print0 option and pipe to xarg0 is your friend here. Cool. All right. How are we doing on time here, John? Ooh.
We have about 8 more minutes.
All right. I wanted to throw in kind of a stumper question this time around. So let me catch up on the slides here. I'm calling this one the Haemer Hammer. All right. So named after my good friend Jeff Haemer, who I met as a result of doing the Command Line Kung Fu blog. We started doing Command Line Kung Fu, and there were a bunch of people who would very often write in with useful tidbits to extend our Command Line Kung Fu episodes. And one of them was my good friend Jeff Haemer, who's an old school Unix guy like me. And Jeff, not only would send us useful things that we hadn't talked about in the episode, but he'd also send us these wonderful little challenges like this one. Okay, so Jeff at the time was working as a release engineer, and he had this challenge, which is he had multiple versions of this software development project that he was working on. And he had all of these date-stamped directories running around. So as you can see, he had like version 1.2, which is the current shipping version of the product, and he had version 2.0, which was the current development path. But each one of these had various dated versions, dated check-ins that the developers had did, and he had these directories that were just blowing up with all of these old date-stamped directories that he wanted to get rid of, all except for the two most recent ones. Okay, so if you have this random pile of directories with different version numbers and different date stamps on them, how do you, for each versioned directory, remove only the ones not the most recent two? Okay, and you couldn't rely on the actual date that the directory was created, because the timestamps on the directories were all wonky due to updates and things like that. So you actually had to use the file name portion to decide which ones to delete. Okay, this is not an easy challenge. And we got a lot of these kind of stumper questions coming in to the Command Line Kung Fu blog, and I wanted to kind of talk about my approach for dealing with these kinds of shell conundrums like this. And the most important thing is to break it into pieces, right? So what are the pieces to solving this problem? Okay, so figure out the different version numbers, right? So we've got version 1.2 and 2.0 in the example, but there might be other version numbers. So the first thing is we've got to figure out the unique version numbers, right? And then we've got to figure out how to decide, what are the two most recent directories that we want to keep and, get rid of everything else. And then we need to figure out, how to actually remove the directories that we want to remove. Okay, ready? Okay, I actually need to make some test data. Let me not be root to do this since I'm going to be removing files. So I'm going to make a test directory. Okay, so for version in, I don't know, we'll call this version 1.0, and version 1.2.1 and version 2.0.0 do. And then for date in 2020 0310 2020 for date in 10 to 15 do makedir $version 2020 03 $date. That'll work. Done and done. Okay, so there we go. We've got some test data to work on.
Yeah.
Okay, now, how do we, given a directory of files like this, figure out the versions? Okay, so they're dash delimited, right? So ls pipe to cut, where the delimiter is dash, and I only want the first field, right? Oh, but I only want one copy. All right, fair enough. There we go. Okay, so there are the different version base names for the directory. Okay, cool. So that's step number one. Now the question is, for a given version, how do I figure out which are the two most recent directories that I want to keep, right? And this is a hard problem. And when Jeff sent me this one, I spent a long time thinking about it until I realized that I was thinking about it the wrong way, right? I kept thinking about it as, okay, so what are the two most recent directories? And, I'm like, oh, well, that's, that command, and then I'm going to pipe it into head -2. Right? Oh, no, that's the old ones. I meant tail -2, right? Like, okay, yeah, cool, right? Like I've got the two most recent directories. Oh, but the problem is those are the ones I want to keep, not the ones I want to remove. Oh, and it was that sort of epiphany that made me realize I was asking the wrong question. The question I want to ask is, what are the directories to remove? And that's everything except the two most recent directories. And when you state the problem like that, it maybe becomes a little more obvious. ls. So look, if I do ls -d, right, I get them in the sort of normal date sorted order, okay? And that means that the most recent directories will be the last two. So like, for example, if I pipe it into cat, so you can see them in order. Okay, right, they get listed in this order with the two most recent directories, the one I want to keep down here at the bottom. That doesn't help me, right? What I want is them to be at the top so that I can filter them out and give me everything else. Because I might have 15, 18, 20, I don't know how many directories I have that I want to delete, but I know that I have two that I want to keep. So ls minus dr reverses the order. And now I want everything except the first two directories. Skip to the third line. So tail -n allows me to specify the number of lines, and +3 means count from the beginning of the output, not the end. So show me everything starting from line 3 is what this gives me. Boom, there it is. Okay, and that's actually one. That's what I want. That's the list of directories I want. Everything except the two most recent ones. Right? It took a while for me to wrap my brain around this. Okay. So for any particular version, I now know how to get the directories I want to delete. And actually removing the directories means just putting all of this into a loop. Okay, so I have the command that gets me the different directory versions. So for version in the output of that command. So the $parentheses means substitute in the output of that command as the things I'm going to iterate over. Do. Okay. So for each version, I am going to ls minus dr $version star pipe to tail minus n +3 done. Okay. And there is the list of directories that I actually want to delete. Okay, how do I delete them? Oh, we actually talked about that command already. I have a list of file paths that I want to do something with. Xargs, rm minus rf. Booyah, there you go, right? Now, like by itself, right, that's a really difficult command line to figure out. But if you do it in pieces and then just kind of plug the pieces together, like Legos, that's how you do kung fu in the shell. That and knowing what all the pieces are and their various options. But I mean, you can do these really neat little things in the shell by plugging all this stuff together. And thanks again, Jeff, for that little stumper question, because it's a nice little bit of kung fu there. All right.
Cool. Because when you look at it, you're like, oh, this won't be hard, and then it is a little complicated.
Yeah, and then you start thinking about it, and you go, oh wow, yeah, that's kind of hard. Yeah.
So, no, dude, wicked. We have a handful of questions. Can you stick around for a few minutes and answer some?
Yeah, sure.
So we're gonna kill the recording. We'll do our final words, and then we'll stick around for a few minutes. So, Hal, any final words?
Yeah, so we blew up the chat at the end of the last one. I asked for people to type a word into the chat to indicate that they were interested in a full day, costs you money kind of command line training. And let's just say the response was overwhelmingly positive. So we don't need to do that again. I've been talking with the Black Hills folks, and we're looking at maybe making that one-day training a reality in the near future. So continue monitoring the Black Hills channel. The other thing is just throwing a shout out to my friends at KernelCon. They're doing a virtual con next week, and I will be teaching Linux Forensics, 2 days, Wednesday and Thursday of next week, and there's still time to register. So another thing that we got a lot of in the questions from last time is, we want more forensics. Okay, you want more forensics? Sign up for my Linux Forensics training at KernelCon next week, and I'll give you 2 days of Linux Forensics from the Linux command line. KernelCon.org, kernel like a popcorn kernel. And you can just look at my Twitter feed, and it's all over that. Thanks for listening. If you have questions afterward that we don't get a chance to answer, there's my contact information. Feel free to email me.
Someone mentioned the plant over your right shoulder, Jason, and it does look very like anthropomorphic. Like it's got arms hanging down and like a hoodie.
Oh God. Check out the Discord. Jason's plant has become a meme.
Oh no! No way.
Oh, that's awesome.
Oh man. Oh, that is so cool. Good.
Now, here's the deal.
Look, now Jason's
Caption: Sad Plant. Infosec Sad Plant.
Jason.
Look at Jason right now. He looks like the plant.
Yeah, you guys actually look alike.